relations and inverses. All right, first one says to find the xy pair of the value of the parameter. So 2, we have x equals 5t minus 7, y equals 17 minus 3t, and that's for t is equal to -2. So basically we just take that t value and plug it in for t and x and y, and we get an xy pair. So x equals 5 times -2 minus 7. And what do I get when I plug that, or when I add, multiply, whatever you want to say, that? -17. Do the same thing for y. Y equals 17 minus 3 times -2. What do I get for that one? 23. So the pair is -17 and 23. Let's see. 4. X equals the absolute value of t plus 3. Y equals 1 over t. Oh, and t equals -8. So we just plug it in. X equals the absolute value of -8 plus 3. Y equals 1 over -8. So what do I get for x? 5. -8 plus 3 is -5. Absolute value would be 5. And then obviously y is just -1 over 8. So the xy pair, 5 and -1 over 8. All right, the next problem is pretty long. You're going to want like probably at least half a page to do it on. So if you like continued it on your notes, you may need to go over for this problem. It says to A, find the points determined by t equals -3, -2, -1, 0, 1, 2, and 3. So we're going to be making a table. And then B, find a direct algebraic relationship between x and y and determine whether the parametric equations determine y as a function of x. And we are not doing the graphing part of that, which is part C. So number 6, and I'm only going to do one of these because it's so long, but it's really easy. X equals t plus 1, y equals t squared minus 2t. So that's what they give you for your problem. And then we are going to set up a table that's going to have our t values, which are -3 all the way up to +3. And then we're going to have another column that's x equals t plus 1. So we'll be plugging in whatever the t value is to that. Y equals t squared minus 2t. We'll do the same thing there, plug it in. And then ultimately we'll get our xy pair. So what happens when I plug in -3 here for t? What's -3 plus 1? -2. And then plug in -3 into the y equation. So -3 squared is -2 times -3 would be 15. So then the point is -2, 15. So we're just plugging it in and then just getting the ordered pair for each one. When I plug in -2 for x, or not for x, but for t and x, what do I get? -1. What about when I plug in for y? Or I'm just going to say for x and for y, but know that I mean for t in those equations. -2 squared is 4. -2 times -2, so that's 4 plus 4 is 8. I like my Algebra 1 class. Alright, what about -1? Plug it in. 0. What about over here? 3. So 0, 3. 1. 0. So we get 1, 0. What about when I plug in 1? And the other one? So 2, -1. Plug in 2. The other one? Zero. So 3, 0. And last one, 3.
4. 3.
So 4, 3. So that's all part A. There's 3 parts, but we're only doing 2 of the 3. All right, part B. Find a direct algebraic relationship between x and y. Determine whether the parametric equations determine y as a function of x. So basically, what they're telling us to do is solve for t. And we're going to plug it in then, like, when I solve for t, I'm going to do so with x. Then I'm going to plug that in for t and y and get an equation. So how do I get t by itself in this x equals t plus 1? Subtract 1. So t equals x minus 1. So now what I'm doing is I'm going to take this and I'm going to plug in for t and y. Okay, so I'm going to have x minus 1 squared minus 2 times x minus 1. So y equals x minus 1 squared minus 2 times x minus 1. And then I just need to FOIL and distribute. What happens when what is this? first one.
I know what it is. I know what it's here.
Perfect square trinomial. So what do I get when I multiply that out?
X squared minus 2x plus 1.
Yep, x squared minus 2x plus 1. And then what about when I distribute that negative 2? Plus 2. Combine like terms, and I get x squared minus 4x plus 3. Is this a function? Does it pass the vertical line test? Yes, because what shape is this? A parabola. So yes, y is a function of x. So that's part B.
What's part C?
To actually graph it. No, we're not doing that. So just something to like note. Parametric equations allow us to graph curves that are not functions, which is what we use them for. I wouldn't stress about this too much because parametric equations really aren't a big part of the AP exam. It's actually like extremely minimal, so I wouldn't be too stressed about it. But I do want you to see it because in calculus we do use them some, so just did them the other day actually. Okay. 9 through 12 say they give you a graph of a relation. It wants to know, is the relation a function? And then does the relation have an inverse that is a function? So 10 is a graph that looks like this.
Oh, it's a sine of x equation. Is it passing through 0 there or not?
No.
Oh, it's not. It's supposed to be passing. Okay. That took way too many tries.
So
It's shifted horizontally.
that's not what we're doing. It says, is the relation a function? For it to be a function, what has to happen?
Pass the vertical line.
Pass the vertical line test. Does it pass the vertical line test? Yes. So for part A, it would be yes because of the vertical line test. So VLT is vertical line test. Just showing how we checked that it was a function. Now part B says, does the relation have an inverse that's a function? So we use the horizontal line test for that. And if it passes the horizontal line test, it does have an inverse. If it does not, then it does not. Does this pass the horizontal line test? No. So there is no inverse for this function. Let's see. Number 12. It looks something like, close enough. Something like that. It's a little more symmetric on the axis there when in the book, but it's close enough. So this is not a function. It does not pass the vertical line test. But does it have an inverse that's a function? Yes. From the horizontal line test. So that's all you have to do for those ones. You don't have to redraw the graph when you do those in your homework. I mean, if you want to, you can, but you don't have to. All right, any questions about that stuff so far? Sweet. Okay. Find a formula for f inverse of x. Give the domain. We're not going to do that part. We're just going to find the inverse of the function. So number 14, f of x equals 2x plus 5, and we are finding the inverse. So to find an inverse, we swap x and y, okay? Just as a reminder, f of x is the same thing as y, it's just a different notation. So we swap x and y. So we're going to have x equals 2y plus 5. And just something to note, which we'll see in another problem in a minute, but if there's multiple x's in the problem, there's multiple y's that are going to get put into the problem. Okay, there should only ever be one y to start with, so there should only be one x when you're doing them. So now I've swapped x and y. I need to solve for y. So how do I get y by itself? Subtract 5. So x minus 5 equals 2y. Now what? Divide by 2. So y equals x minus 5 over 2. Now, we're going to do some of these later where they want us to confirm that two functions are inverses of each other, but I'm going to show you a way to check them so that you don't have to worry about ever getting an inverse wrong, because you can check it. We can plug in f of f inverse and vice versa, it doesn't matter. I'm going to plug in this function, just note this here so we know what this is, for x up here, and if it comes out to be equal to x, then it is an inverse. So this is going to be 2 times, I'm replacing x with x minus 5 over 2, and then plus 5. So the 2's cancel from the multiplying, so I have x minus 5 plus 5. Negative 5 and positive 5 obviously cancel each other out, so I'm left with x. So that is its inverse. So I've done it correctly. Now, some of them are easier to check than others. That was an easy check. Some of them are a little more difficult, but you can always check with that method, or I can do it the opposite. I could have plugged 2x plus 5 in up here and then done it that way as well. It'll work both ways. 16. F of x equals x plus 3 over x minus 2. So we are going to swap x and y. So x equals y plus 3 over y minus 2. So notice this one has 2 y's in it, as well as obviously the one x. So I swapped anywhere there was an x, there's now a y. So I need to get y by itself, okay, but this is a different one than what I'm sure you're used to. So what I'm going to do is I'm going to multiply both sides by y minus 2. So I'm going to have x times y minus 2 equals y plus 3. I'm going to distribute over here. So I have x times y minus 2x equals y plus 3. So now at this point, what I need to do is I need to get all the y's to one side and everything else to the other. So I'm going to bring this y over here, take this 2x over here. So x times y minus y equals 2x plus 3. Now, any ideas what I need to do to be able to get y by itself? Take a y out. So y times x minus 1 equals 2x plus 3. So then divide by x minus 1, y equals 2x plus 3 over x minus 1. I'm not going to check this one because there's going to be one like this in the actual checking section, and it takes a really long time to check these. So just know that I checked this is the right answer, but we'll check a different one later. Thanks. Let's see, 18. F of x equals the square root of x plus 2. So Emma, just so you know, we're finding inverses right now of a function. So swap x and y. So I have x equals the square root of y plus 2. How do I go about getting y by itself? What do I need to do first? Square both sides. So I get x squared equals y plus 2. And then just subtract. So y equals x squared minus 2. And that will be your inverse. See, 20. So this will be the last one of us finding inverses, and then we'll be on to checking them. F of x equals the square root of x cubed plus 5. So much like the other one, first thing I'm going to do is square both sides, or well, actually, no. First thing I'm going to do is swap x and y. X equals the square root of y cubed plus 5. Now I'm going to square both sides. So x squared equals y cubed plus 5. Subtract the 5, so y cubed equals x squared minus 5. What do I have to do now? Because I need y completely by itself. Yep, cube root. So y equals the cube root of x squared minus 5. All right, any questions on actually finding inverses? All right, so there's never a reason to get inverses wrong, okay, because you can always check it. And let's say you check one and you're like, I know this isn't working out to be right, but I can't figure out what I did wrong. If you have a quiz or test, like, write that. Like, show me that you checked it so, like, you know it's not right, and just be like, but I can't figure out how to fix it, okay? Because that shows me that you at least put in the effort to be like, oh, hey, I did something wrong, but I can't figure out, like, what's wrong about it, okay? So we're going to check a few, and we have to check them 2 directions because that's what it says to do. So they say to find or confirm that, what is happening? Okay. F of g of x is equal to g of f of x is equal to x. So basically, if a function is an inverse of another one, then when we check them either direction, it should come out to be equal to x. And that'll show us that they are truly inverses. So the first one is 28. I've got f of x equals x plus 3 over 4. And g of x is equal to 4x minus 3. So when I have this here, I take whatever g of x is, so the 4x minus 3, and I'm going to plug it in for x and f of x. So the first one I'm going to do is f of g of x. So I've got 4x minus 3, and then plus 3 over 4. Negative 3 and positive 3 go away, so I'm left with 4x over 4, which reduces to x. So that direction works. Now, you always have... Now, hold on, let me back up. These problems, you have to do it both directions to check it, okay? When you're checking a problem to see if it's an inverse of each other, if you have found the inverse, you don't really need to do it both ways because if one works, the other one is going to work. So, g of f of x, plug in this over here. So 4 times x plus 3 over 4 minus 3. 4's cancel. I'm left with x plus 3 minus 3. 3's cancel each other out, so I'm left with x. So good to go on that one. Um, 30 is not hard, it's just a little different, so I'm going to go ahead and show you this one, and then we'll do a really hard one. Man down. F of x equals 7 over x. G of x equals 7 over x. Now, do you think these look like inverses? Why? They're the same thing. So an initial glance kind of looks like they might not be inverses. So we're trying to confirm that they are, but it also could be that they are not. So I'm going to do f of g of x first. So 7 divided by, I'm plugging this 7 over x in for x over here. 7 over x. What happens when I divide by a fraction? Keep, change, flip. So I have 7 times x over 7. 7's cancel. Equal to x. So it's good. Now, because they're the same, what's going to happen when I do g of f of x? It's going to be the same thing. If there's ever one you have like that, as long as you've checked one, you don't need to do the math to show the other one. Just know that they're the same as the other one. All right, this next one is going to require a little bit more work, so I would make sure you have probably like, depending on if you're going across, down, whatever, probably like 8 lines to make sure that you have enough room to do this one. Number 32, f of x is equal to x plus 3 divided by x minus 2. And g of x is 2x plus 3 over x minus 1. So we're doing the same thing, but what's different about this one compared to the other ones? There's 2 x's in there, so it's got to get plugged into both x's, which means I'm going to end up with fractions and fractions, need the common denominators, all the things. Not super hard, because what's supposed to happen? Everything's going to cancel. So, f of g of x, I'm plugging this g of x function in for both x's over here. So I get 2x plus 3 over x minus 1 plus 3 all over 2x plus 3 over x minus 1 minus 2. So what I need to do is I need to get a common denominator on the top and on the bottom. Obviously, they are going to happen to be the same thing. That doesn't have to be the case. Just across the top and across the bottom, they have to be the same. So I multiply the 3 by x minus 1 over x minus 1, and I do the same thing with this 2 down here. So I'm going to end up with, on top, 2x plus 3 plus 3x minus 3 all over x minus 1. So that's the top fraction. Bottom fraction, I'm going to have 2x plus 3 minus 2x plus 2 all over x minus 1. For the sake of not having to rewrite everything, I'm going to go ahead and cancel out stuff that cancels. So this positive 3, negative 3 on top cancels. On the bottom, or in the bottom fraction, the 2x and the negative 2x cancel. Divide by a fraction, I multiply by the reciprocal. So again, I'm just trying to save a step of writing. I'm going to do a lot of things in one step. 2x plus 3x is 5x over x minus 1 times, keep change flip, so I'm going to flip this. This is going to be x minus 1 over 3 plus 2 is 5. X minus 1's cancel, and 5's cancel, and I'm left with x. Any questions about how we did any of that, those steps? All right, so what I want you to try for a moment to make sure that, because these are the hardest ones, I want you to do the g of f of x one on your own, and then we'll go over it. So I'm going to leave this so you can see it. So take a couple minutes and try that one, and then we'll go over it, and then I'll give you your homework problems. All right, did we get it?
I finished it.
Okay, I'll give you another minute or two.
I did something.
I just don't want y'all to be sitting there like done and I'm just like chilling up here waiting for y'all. If you are done, did you get it to X?
I got to the last step and I did something wrong. Step 1.
Did you remember to multiply by the 2 that's in front of the X in G of X? Okay.
I got like, I messed up. When I did like x minus 2 over x minus 2 times negative 1.
It's probably just a signs thing then. Did anybody get to X? You did, Tristan? You did a lot of these with me last year, didn't you? All right, I'm going to go ahead and put it up so we can walk through it in case you're stuck or didn't get there. I'm just going to put it this one up only so that it's not confusing. All right, so G of X was 2x plus 3 over x minus 1. Yeah. So we plug in x plus 3 over x minus 2 for x in both of those things. So what I have written in blue is what we started with when you plugged in. Needed to get a common denominator, so I multiplied by x minus 2. And the same thing down here. So when I did this, I went ahead and distributed. Again, I was trying to eliminate writing it so many times. So 2x plus 6, so that's the first part. And then 3x minus 6, all over the x minus 2. On the bottom, x plus 3 just copied. And then negative 1 times x, so negative x. And then negative 1 times negative 2 is positive 2 over x minus 2. At this point, I went through and I canceled out the stuff that's like just on each row that I could cancel. So 6 and negative 6 I could cancel. And then x and negative x I could cancel down here. And so then on top I was left with 5x over x minus 2, which is what I wrote here. I went ahead and did the keep change flip. So I had the x minus 2 on top over 3 plus 2 is 5. Canceled x minus 2, canceled 5, and it was left with x. Did you find out what you did wrong? Okay. Or was it?
It was like I got the top part right, the bottom part it was negative 1 times x minus 2 times x over 2. For whatever reason, I did it like twice.
Oh, okay. Everyone else, did you see where you went wrong? If you went wrong somewhere?
Yeah.
Okay. Any questions about any of this? All right, your problems are 3, 5, 9, 11, 15, 19, 21, 27, and 31. We still have, only 5 minutes left. Clock up there is confusing. No, because on Wednesday, we are going to have a work day on this stuff. That's why if you just let me finish. We have a work day on this because the juniors are gone Thursday and Friday, so we're not going to start a new section on Wednesday. Tomorrow's spiritual emphasis, so no homework tonight. These problems are for you to do on Wednesday in class. And then after you're done Wednesday, you should do the notes for 1.6 because you need those Monday when you come back. So seniors, you have time Thursday and Friday to do them. Also, if y'all want to leave early and take your 15 one of those days to go out to lunch, that's totally fine because they won't be here.
Wait, when are 1.6 notes due?
Monday.
Oh, wow. Just more than a week.
So if you haven't done them yet, then you'll have time Wednesday to do them. Seniors will have Thursday and Friday also. Juniors don't want you to have to do them when you get back from DC, so that's I'm trying to give you time to do that. So anyways, that's that.